Welcome to Natural Logarithms. So we've already discussed logarithms with bases of 10, and in there I talked a little bit about other bases like base 2. So here a natural logarithm is a logarithm with base e, where e there is Euler's number. So Euler's number, e, has a value of 2.718281828459045, and it keeps going on forever. It's a transcendental number, so it never ends, right? This is why I've got these three dots here, right? But basically, we can abbreviate it in most cases as simply 2.718. That's close enough for most of the calculations that we're going to be doing. Written down here, I've got it to an extra couple of sig figs, so 2.71828. But if we take a natural log with base e, then we call that a natural logarithm, and we abbreviate that as an ln here. So if you see something like ln of some value, which in this case I'm writing it as 2.71828, well, if we plug an e in there, right, this value is e, so if we take the natural log of e, then we get 1.0. If we had a log base 10 of 10, we would get a value of 1.0. So suppose we need to calculate the natural log of 5. What we're going to type into our calculator is we're going to hit the ln button, the natural log button, and then we're going to hit 5. Now sometimes the parentheses might show up, so you might have to hit a close parentheses there. This will depend on which calculator you have. So, and then we'll hit the enter button, and we should get a value of 1.6094, and it'll keep going from there. So a value of 1.61 basically, once we round here to the hundredths place. So check on your calculator, make sure that you're getting the same value that I'm getting. If you're getting a different value, that means that you need to go back and tweak exactly how it is that you're plugging this calculation in. So now we've covered how to calculate a natural log. Well, now let's go with how to do the anti-log. So just like with our log base 10, sometimes we're going to need to take the anti-log. Well, with our base 10 logs, we use 10 as the base of our exponent. With our natural logs, we're going to then use e as the base of our exponent. So here's a case where we have to take the anti-log. So if we have natural log of x is equal to 61.3, and we need to then solve for x, we're going to have to take the anti-log. So we have natural log of x is equal to 61.3. Well, remember we need to raise the base of our logarithm. So again, the base of our logarithm in this case is e, raised to then both sides. So e raised to the natural log of x is equal to e raised to the 61.3. And then on the left side here, the e raised to the natural log will cancel because we have the logarithm and the anti-log. So now we just have x is equal to e raised to the 61.3. And when we plug this into our calculator, we then get a value of 4.19 times 10 to the 26. So note here that our e for Euler's number is a lowercase e. If instead you plug into your calculator something like the big E, the capital E, that we were using for our scientific notation, and then you plug in 61.3, in that case you're not going to get the same result. In most cases, typing in something like this should give you an error, because essentially you're missing whatever you should have over here to the left of that. Because remember, we should have some number there, so maybe 7, and then e, and then it should be just a 61. The calculator doesn't know what to do with this 0.3 bit there. Right? Because it's not actually taking 7 times 10 raised to the 61.3. So be very careful that you're using the lowercase e and not the uppercase e on your calculator.